Alrighty, folks. I hope everybody is doing well today, tonight, this morning, wherever this video finds you. So we're looking at 7.1, example number 3. And right now what we're going to do is that we're going to be graphing these radical functions here. We have f of x is equal to the square root of x plus 1. We're going to be graphing f of x is equal to the square root of x minus 5. And then we're also going to be graphing f of x equals the cube root of x plus 1. So these are square roots. This is a cube root. All right. And for all the kind of graphing that we do in this class, I always use Desmos. It's a really cool graphing calculator. So as you can see right here, just go to desmos.com and then I'm going to go to desmos.com. It'll take you right here, and then just go to start graphing calculator, and then bam. Cool. And so what I want to do right here is I want to punch this in right here. F of x is equal to the square root of x plus 1. So let me show you how to do that. So once you do f and then open parenthesis, it already closed the second parenthesis. You can go ahead and put your x right there and just do a right arrow is equal to. Now we need the square root symbol. The way we do square root is you do the SQRT, and that will make the square root symbol. And then you can put the x plus 1 in there. Okay? And then what's cool is that you can kind of go ahead and just click and just drag around and see the whole graph. You can zoom out if you like. You can zoom in. It's a pretty nifty graphing calculator there if you ask me. So bam, I mean, like there it is. That's what the square root of x plus 1 looks like when you graph it. But I also want to talk about, what is the domain and range? Because a lot of times when you graph things, they want to know what is the domain and range. So let's talk about that. Let's first talk about domain. Okay. Anytime that you're asked to find the domain, it's referring to the x-axis, and specifically, the domain are what values, specifically what x values, and this is the x values right here, what x values are used to graph this function right here, what x values. And what I mean by that is if you were to plot points here, right, so like this point right here would be the point -1, 0. See how it uses the x value -1? Okay, and how about the x value of 0? We'll see how it uses the point 0, 1. So we know it uses the x value is -1 and it uses 0. But it also uses points in between here, right? I mean, if you look like that's a point, 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 that's a point. If you get my point, no pun intended, it used every x value between -1 and 0, right? Well, what about from the x value from 0 to 1? Right, like right here. Well, yeah, look, it uses that point, that point, that point, and if I just move my cursor along, it uses all of these x values. See? So to try to make this simple now, it uses the smallest x value is -1, and it used the x value of 0, 1, it used 2, it used 3, 4, 5, and it's going to just keep going and going and going, right? It's going to use every single x positive value. Just going to keep going and going and going. I mean, right when I'm at 58, you go, yep, it used the x value 58. If you keep going here, I mean, it used the x value of 100, right? So that's the point right there, 110.05, right? So the way that we want to say this now is we want to say that the domain are all of the x values starting from -1 all the way to infinity. And let me show you how we represent that. Okay, so the way that you want to do that is you want to do it like a D, like domain. It's going to start at -1 and it's going to go all the way to infinity. Now notice the way I use my notation. I use a bracket to indicate that that number is included. So we use a bracket for -1 because that's -1 is part of that domain. However, infinity is not a number, right? Like you can't say, oh, I have infinity dollars or I reached infinity. This just represents like every single positive number. So because you can't get there, we use in mathematics these parentheses to show that it's not included. It approaches it, but it's not included. Okay? And the same thing for the range. If we kind of look at how do we find the range? The range are what are the y values? Look at the y-axis. What are the y values that are used to graph this? Well, if you look at this, the smallest y value is 0. See, that's the y value 0, -1, 0. So now we don't care about the x value, -1. We just want to know what is the lowest y value. And then look, and then it's also going to use the y value 1. It will use the y value 2. See, so there's the y value 2 right there. If I can get it right there on my cursor, it's going to be close. There it is, 3, 2, right? But we don't care about 3. We're only looking at the y value. So it used the x value of 0, or the y value of 0, 1, 2. It's going to use 3, right? It's going to use 3. It's going to use 4. It's going to use, I mean, look, this thing's going to keep going up and up and up and up and up, right? As you can see here. So the way that we want to represent this is we want to say that the lowest value is 0 and it goes up to infinity, but we're going to use parentheses because it never reaches it there, but it does include 0. See, the lowest value is 0. Great, so that's the first one right there. So we graph it pretty simply using Desmos, but then we can find the domain and range by understanding what x values and what y values are used. Great, so let's go ahead and just try this guy out. The square root of x minus 5, and we'll go a little quicker here. So let's do our little function here. Again, squirt, S-Q-R-T, of x plus 5. Great, and was that x plus 5 or x minus 5? Oh, it's x minus 5, so let's change that real quick. Great, and you can get rid of the first graph by just clicking on this guy. It's kind of cool. Okay, so let's look at domain. Domain again means what x values were used to graph this. Well, the smallest x value is 5, and it used 6. It used the x value 7, it used 8, it used 9, and as you can tell, it's going to keep going. So it goes from positive 5 to infinity and beyond. So let's write that down. So the domain is from 5 to infinity. Notice my bracket, and then I use parentheses. You will get dinged on any assessment or assignments if you submit the wrong usage of a form here. So that's why you gotta know the difference between when to use a parenthesis and when to use a bracket. And then for the range, it will be the same thing from 0 to infinity. Why? Well, if you look again, the smallest y value is 0. That's the smallest y value. And then how high up does it go? Well, this is going to keep going on and on forever. And so that's why the range from 0 to infinity. Okay. Lastly, let's do the cube root of x plus 1. Okay. And so the way that we kind of do that one, it's kind of like this tricky notation. But what you do is you do x is our base, and I'm going to do a fractional exponent. So I'm going to use the 6 key, but it has like a little caret. So I'm going to use Shift 6, and it kind of makes the exponent, the cursor go up on the exponent. I'm going to do 1/3, and I'm going to use the right arrow to go back down, and then plus 1. Let me get rid of this guy. Cool. So that is the the cube root of x plus 1. If you're looking at this like, dude, what the heck is that? So basically, I'm just doing a different notation. So the cube root of x is the same thing as saying the x to the power of 1/3. Okay, we learned about this, I think it was in either example 1 or 2, but we learned that you can write radicals as fractional exponents. They are exactly the same. And so I just had to write it like this so that the computer can understand what I'm trying to do here. Okay? Great. So as you can see here now, if we look at the domain, what is the what x values are used to graph this? Well, look, I mean, this thing used 0, it used -10, -20, -30, -40. I mean, this thing's going to go on forever, and it's going to go on forever to the right. So that means our domain, right, is going to go from -infinity, and notice I use parentheses, to +infinity, and notice again I use parentheses. Okay? And what about the range? If I look at my y values, well, it's kind of hard to see here on the graph, but this thing is, it is going higher and higher. It just takes a long time, but as you can see here, the line is going higher and higher. It's going up, and it's still going, and we're at 880, and it's going to keep going up. I mean, but when you zoom out, it looks like it gets smaller or it flatlines, but that's just the limitation sometimes of a graphing calculator. But this thing just keeps going up and up and up forever and ever. Like as you can see here now, it's kind of to go up again. It takes a long time, but it most definitely will. So the way that we say that is that then our range is the same thing as the domain. So our range is from -infinity to +infinity. And there it is.